Hello friends, welcome to the video tutorial on Firebird 5 Robotics Research Platform. This platform is based on Atmega 2560 microcontroller, which belongs to AVR architecture based microcontroller family. In this tutorial we will learn about LCD interfacing on Firebird 5 robot. Now let us see the agenda for discussion in this tutorial. The presentation will start with the overview of LCD. Then we will discuss about LCD pin configuration, which will include the discussion of control and data pins of the LCD. After understanding the pin configuration, we will discuss how to send command and data to the LCD and then write a program to display some string on the LCD. So what is LCD? Liquid crystal display, or LCD in simple words, can be defined as a thin flat panel device used for displaying some kind of text or images or animation in a user-defined format. So LCD are economical and easy to use device, which makes it suitable for being used as display device in any embedded system application. LCDs are available in various flavors and are characterized by character set it can display. A commonly available LCD can display 16 to 20 characters in 1 to 4 lines. There are some typical embedded systems like calculators, digital clock, etc., where we usually see the application of LCD. So the LCD we are using is referred as a dot matrix liquid crystal display. This LCD has a Hitachi manufactured LCD controller referred as HD44780. The LCD is a 16 by 2 alphanumeric LCD because LCD can display 16 characters in 2 lines, and character can be both alphabet and numbers. HD44780 is a standard LCD controller used to drive any dot matrix LCD with 8 or 4-bit microcontroller. This is a typical 16 by 2 dot matrix LCD which we are using. Now let us see the pins of LCD in details. LCD is a 16-pin device as shown here. Now we will see the function of each pin one by one. First pin is VSS, or the ground pin. Second pin is VDD, or the supply voltage. Third pin is VEE, or the contrast voltage adjustment pin. Normally a pot or potentiometer is connected at this pin, and by changing the pot, contrast of LCD display can be changed. Then fourth pin is RS, or register select pin. Fifth pin is RW, or the read write pin. Then we have a enable pin represented by capital E. Pin D0 to D7 are the data pins used for sending commands and or display items. Last two pins are VDD and VSS and are used as backlight supply for the LCD. Now let us discuss the pins in more detail. For ease of understanding, we have divided pins in two groups. The first group we call as control pins. These pins are used for controlling the way LCD works. The first pin in this group is register select, or the RS pin. This pin is used to select command or data register. So if RS is mid 0, command register is selected and anything put on the data bus is taken as command for LCD to work in certain desired way, which we will discuss in the coming slides. So when this pin is low, data on the data bus will not be displayed. If RS is set a value of 1, data present on data bus is displayed on LCD in a way as set by user, giving certain set of commands. So next is the read write select pin. This pin is used to select whether we want to write on the LCD or we want to read from it. So if we write RW equals to 0, it means we are writing to the LCD. And if we write RW equals to 1, it means we are reading from the LCD. The third pin in this group of control pins is the enable pin. So the enable pin is used to latch the data present on the data pin. Now as a user, we can send different data at different times, and LCD needs to differentiate amongst them. So for this, LCD latches the current set of data on the data pin until the next data is not needed. So for latching, we need to send a high to low pulse on enable pin whenever new data is to be sent over the data pins. So the LCD interprets and execute our command at the instant the enable line is brought low. If you never bring enable pin to low, data on data pins will not be read at all. Okay, so with this we complete the discussion of using control pins of the LCD. Now next group of pin is known as data pins. Let us look at those in detail in this slide. So here there are total 8 data pins named from D0 to D7. Same 8 data pins are used to send both the commands and the data. The LCD is alphanumeric type and understand only ASCII format. So we can interface LCD in either 8-bit mode or in 4-bit mode. In 8-bit mode, all 8 data pins are connected with microcontroller, whereas in 4-bit mode, only 4 data pins are connected to the microcontroller. So generally, in order to save microcontroller pins, LCD is interfaced in 4-bit mode only. In Firebird robot, the LCD is interfaced in 4-bit mode, so data pin D4 to D7 is only used for interfacing. Now let us see the pin connection between LCD and Atmega 2560 microcontroller. As shown in this figure, control pin of LCD, that is RS, RW and enable, are connected to port C pin number 0, 1 and 2 respectively. The 4 data pins of the LCD are also connected to port C from pin 4 to pin 7. Now let us look at some important and commonly used commands with the LCD interfaced. The first command in the list is used for initializing the LCD in 8-bit mode. So if suppose LCD would have been connected in 8-bit mode, then we would have sent a value of 38 over data pin, and as the data pin is sending command, we should have kept the value of register select control pin as 0, that is set it in the command mode. Now in our case where LCD is interfaced in 4-bit mode, we need to send the value 28 over the data pin in order to tell LCD that it is interfaced in the 4-bit mode. Next command is to clear the display of LCD. When LCD is clear, it means nothing is being displayed on it. So this can be taken as analogous to erasing everything from the classroom board when new teacher starts giving a lecture. So the hex value for clearing the display is 0, 1. Return home means cursor comes to the first row, first column on the LCD. Similarly, there is a command for making cursor blinking. So when you want cursor to blink on LCD, set the hex value of 0F as command. This is the address of first character on first line. You can similarly increment this value by 1 to move on from one character right. Similarly, C0 is the address of first character on the second line, and 0C is the command when you don't want a cursor to appear on the screen. So these were few set of commands commonly used. You can find more such commands in datasheet of HD44780, which is sent to you in the folder for the Firebird robot. Now LCD is a device connected to microcontroller, but before using it we have to initialize the LCD. So in this slide we will see steps for LCD initialization. So the first step will be to define the ports where LCD is connected as output. So in case of Firebird, LCD is connected to port C. So define port C as output port, and after defining it, our next step is to set the control pins. So in this stage we are going to send some commands to initialize the LCD. So RS and RW must be given a low value, that is RS and RS should be equals to 0 and RW should be equals to 0. Next we will send value of 0x28 to tell LCD controller that it is interfaced in 4-bit mode. The value 28 on data pin will be read only when we send a high to low pulse on the enable pin. So this comprises our third step. After this, we will send some commands which will set LCD in a default mode. So we will first send a command to clear the display screen. This is desirable because it may be possible that previously LCD has something on its display, and if we send some new display text, it will overlap with the previous display text, which is unwanted. So by sending a value of 0x01, we are clearing the display of the LCD. Then we make the display on for LCD in order to see what is being displayed at LCD. Lastly, we have placed the cursor at home position, that is first line, first character. All these steps are very important, without which my LCD will not work. We will see how to use it once we start writing the program. So let us now begin writing the C program. In this slide, we will put the syntax for writing the C program. So the standard C program begins with including the header file. Here in this program, we include some header files which are has include avr/io.h, has include avr/interrupt.h, has include util/delay.h, and has include lcd.h. Now here we have included new header file by name of LCD. This header file comprises of many built-in functions which you can use to easily program the LCD. We will look at the content of this header file in the next slide. For now, make a note that whenever you use this user-defined header file, you need to copy the header file into your project folder. This header file is given to you in the folder named header_file. So just copy the file from that folder and paste it in your project folder. Let us now look at the main program. In main program, we have called various functions. These functions are written inside header file, so it can be used directly. The first line is init devices function, which is similar to one we have used in other previous program also. It will include the port configuration function. So for LCD, port C needs to be set as output. So next function is LCD_init. This function contains the LCD initialization, which we already discussed step by step in previous slide. Then the function LCD_cursor places the cursor at first line, first character. So this function actually contains two parameters. First is row number and second is the column number. The function LCD_string prints the string from the location specified by the LCD_cursor function. So in this example, we are printing e-Yantra from first line, first character, and IIT Bombay from second line, third character. We have already understood few functions of header file in the previous program we discussed. Now let us see all functions defined inside the header file. It is suggested that you open the header file and have a look at how functions are defined in it. So the header file is in C language. As I have stated earlier, for any user-defined header file you use in the program, you need to copy that into your project folder. The first function is of init devices, which defines port where LCD is connected. Then we have LCD_init function, which initializes the LCD in 4-bit mode. LCD_WR_command function is used for sending command over the data pins. You can send hex value of command as parameter of this function. For example, if you want to send 01 for clearing the display, you can simply do it by writing LCD_WR_command within brackets 0x01. The other steps for setting control pins and latching data is already defined in this function. LCD_WR_char function is used to print single character at a time. It can be used when you have to display some numbers or single letter. For example, try to display letters from A to Z one at a time with some delay between each letters displayed. So at that time you can use this function. Then we have a function named as lcd underscore string. We have already used this function to display a string of letter in the example discussed in the last slide. lcd underscore cursor allows us to choose the location to start displaying by specifying the row and column position. The last function is of lcd underscore print. This function has 4 parameters: row, column, value and digit. Row and column specify the location, value is the integer value we want to display on the LCD, and digit allows us to control the number of digit we want to display. Suppose if we have value in 5 digit but we want to show only 3 and truncate the rest 2. So we can simply put values as 3 in place of digit in the function parameter. So here we have successfully understood the concept of how to interface LCD in the AVR based microcontroller. So now let us look at the demonstration. We will start with writing the C program for LCD interfacing on Atmel Studio 6. So open Atmel Studio by clicking on the icon from here. Follow the steps for creating new project as demonstrated in the video tutorial of Atmel Studio 6. I have already created a project in the folder named as lcd underscore interfacing. So let me open the project from here. Now browse the folder lcd underscore interfacing and open the Atmel Studio 6 solution file. So here we can see our program open. Let me just increase the length of it. So as you can see here, the first line of our code is has defined fcpu 14745600. This sets the clock frequency in Hertz on which the robot is operating. It depends on the crystal frequency attached on the robot. In case of Firebird 5, the crystal frequency is 14745600 Hz. Then we have the standard header files like avr/io.h, then avr/interrupt.h, avr/util/delay.h. The last header file is a user defined header file, and so it is written in double quotes as has include lcd.h. Being a user defined header file, we need to have this file inside the project folder. This header file is given by us in a folder named header file inside Firebird 5 Atmega 2560 folder. So you must remember to copy this file to the project folder. Let me do it here. This is the folder. Inside this there is a header file folder. So copy this file and paste it inside the project folder. So I have my project folder here, lcd underscore interfacing. Open this and then paste the file. Since I have already a file there, so it's asking for replacement, so I'll just replace it. So you can see here there is the file lcd.h. This process should be followed whenever you are using any user defined header file in your program. Next in the program we have a function called as lcd underscore port underscore config. This function defines port C, pin 0 to 2 and 4 to 7 as the output pins. Remember, LCD is interfaced at these pins of microcontroller. Next is a standard function of init underscore devices, in which first line is to clear the global interrupt, Then call the port configuration function and then set the global interrupt. After this, we have our main program. This program is already explained in the slides. It will display e-Yantra in the first line, first character, and IIT Bombay in second line from third character. Note that string to be displayed is written inside double quotes in the function lcd_string. Now let us build this function by clicking the button for build LCD from here. In the output window you can see build succeeded with no error. So we have successfully written our program, and now we can load the hex file into the microcontroller on the robot using AVR bootloader and see the output on the LCD. So let me open AVR bootloader software. In this, select COM port number, which in my case is COM7. Set baud rate as 115200. Then select microcontroller as Atmega2560. Then browse the hex file from the project folder, which is on desktop, inside this LCD interfacing debug folder, and then you can see that Intel hex file. Now switch the robot in bootloader mode by pressing and releasing the reset switch with boot switch pressed, and then release the boot switch. Then click on the program button and wait for program to load. Once the code is loaded successfully, switch off and on the robot. So you can clearly see here that we have got the desired output. So here we have successfully understood the concept of LCD interfacing and its operation in AVR based microcontroller, and have written a program for displaying some text on the LCD. You can experiment with codes and try making moving display with some text, or design a counter that can count from 0 to 100, or any small animation you wish. With this, we have come to the end of this tutorial. Thank you for listening. For any queries, you can visit http://qa.e-yantra.org. This is Saurav Sandalia signing off.